Hey everyone, I'll introduce Geomatic in this video and specifically I'll talk about reactivity, which is one key property of Geomatic. I want to start with the interface, which is mostly the canvas, and at the bottom is a text box where you can type in commands, and on the right hand side you have a panel where you can see the history of all commands that have been executed. Let's start with the commands now. Every command follows one format, which looks like output variable equals backslash command name followed by input variables. And one thing to note is that specifying the output variable is optional, which means you can simply type out backslash command name followed by the inputs, and the system will automatically assign an output ID for you. Let's try out a few examples. I'm going to type backslash line A space B, which creates points A and B and joins them with a line. The thing to note here is that the points A and B did not exist before. So what happened was that the system generated points A and B randomly and then joined them with a line. One can also create other shapes like a triangle with points A, B, and C as vertices, or let's say a circle with the point P as center and R as the radius. In this case, point P and radius R do not exist. So it's going to auto-generate these two nodes first, which are going to be random values, and assign them certain values and then draw a circle with those values. And this system is reactive. What it means is that if I change any of these input values, all the other nodes which depend on that input will also update reactively. For example, if I update R to something like, let's say 2, the radius of the circle will update immediately. Similarly, if I create a line with points A and B, and let's say I calculate the midpoint of this line using the midpoint command, and then if I modify A, for example, let's say A is equal to the origin, the point at 0, 0, the line AB and also the midpoint update immediately. And that's a key property of Geomatic. Everything is reactive by default, which means you specify the whole system once, and if you want to go back and change something else, everything downstream updates immediately. Let's take a look at a few more examples. Let's say you have a triangle A, B, and C, and let's say you want to draw a circle at point B whose radius is equal to the side BC. So it's going to look something like circle with center as point B and the radius, we don't know the value yet, but it's going to be a function of points B and C. So what we'll do first is we want to find out the radius, assign it an ID R, and the radius is the distance between points B and C. It's R, and then we draw the circle at point B with radius R, and this is what we get. And again, the whole thing is reactive, which means if I move my point B to somewhere else, let's say if I move it to let's say -4 and 0. Oh, this is okay. -4 and 0, the whole thing updates immediately. So this is pretty useful to have, because what you can do is you can just initialize a system with random values first, and then you can update them without worrying about whether the downstream components have the correct values or not. And second cool thing about reactivity is that it helps you animate something that's sophisticated. For example, let's say this whole system depends on point B, and what I can do is, let's say I can move point C a little bit. For example, if I translate point, oh, not trail, if I translate point C by 4 units to the right and 2 units along the y-axis, the whole system updates in the form of an animation, because translate command basically translates something frame by frame, so it's an animation. And if an input value is being updated frame by frame, it's gonna update the whole downstream component frame by frame as well. So for example, here we have this node A, which can be updated. Let's say we translate it by -3 and 0, and we do it again, and it creates this smooth animation for translation. And we can make use of reactivity and animation of input parameters to create sophisticated animations. Let me show you one example of that. So if you go to examples here, we open this link about linkage, and the way it works is it creates the whole setup for this linkage first, and let's wait for a bit, and then we create this output point, which is this reflected point, which is a function of all this sophisticated machinery or sophisticated geometry that you see on the left hand side. And what we want to do is we just want to animate this point P2, and because this output point P final depends on P2 and everything else, it's gonna react to changes in P2. So if we animate P2, this point will also be animated. And the cool thing about this linkage is that if P2 rotates about this point, that rotation is converted into a linear motion by this linkage. So this point P final is going to move along a straight line. So let's see if it works or not. Yeah, it does. Anyway, let's go back and let's clear the whole thing. Now the second thing is that reactivity is useful, but sometimes you don't want a system to be reactive. For example, let's say you're given a line AB with a midpoint M, and if I make any changes to points A or B, M is going to react to it. For example, if I set A to -3 and 0, M is going to update as well, which is cool. But let's say if I want M to stay here, and I want to move A later, but I don't want M to react to it. How do I achieve that? That can be achieved by translating M by 0 and 0, which is effectively not translating it at all. But by running this command, what happens is that it doesn't have any visual effect because we didn't move the point M at all. But by running this command, M became the output of this function translate with parameter 0 and 0. So M is no longer a function of point A or point B, which means M is not going to react to changes in A or B. And let's verify that. So I'm gonna translate A to -3 and 0, and as you can see here, M does not react to changes in A or B. So I can also set B to, I don't know, 0, -3, and the line AB is still reacting to changes in points A and B, but the midpoint is not. So this is how you can break reactivity. If you want to learn more about reactivity and some patterns, you can check out this article under examples. It's titled About Reactivity, and it goes deeper into some patterns of reactivity and how it works and how you can break reactivity. That's it for this part. Thank you.